All right, we're going to finish up 9-4. We're doing 9-4 day 2. And we are going to pick up where we left off. I had done the cosecant reduction formula with a number, and we came up with what our guess was here, and then I didn't go into the end one. I'm going to do that now. Just wanted to make that day one a little shorter. So we are going to start out with cosecant to the nth, and our trick to starting it was to pull off a cosecant squared because that has an antiderivative. So we're going to start out the same way. So number one, we're going to develop the cosecant to the nth reduction formula. And again, the trick was to pull off a cosecant squared. So if I take 2 away, that's going to leave me with cosecant to the n minus 2. So now we'll do one iteration here. So derivative here, the power comes down to the 1 less. So now that'll be n minus 3. And then times the inside derivative. And the inside, so cosecant's derivative is negative cosecant cotangent. So I need a negative cosecant cotangent. Got a little long. Okay. Over here, we're going to do the antiderivative. So we ask ourselves, what has cosecant squared as its derivative? And negative cosecant squared has is the derivative of cotangent. So we just need to throw on the negative. So it's going to be negative cotangent. So now here's our diagonal. First diagonal. Oh, before we do this one, I got to bring these cosecants together. So I've got cosecant to the n minus 3, and this is cosecant to the first. So you add exponents. So these two terms are going to come together and make cosecant to the n minus 2. And then the rest of it just comes, x, cotangent x. All right, and then here's our integral. Negative, integral, positive. All right, so here we go. It's about, I'm on this line, so it's 1, 2, 3, 4, 5, 6 lines we should have it. And again, don't just copy, have it make sense. Think your way through it, why each line is the way it is. So we first are just multiplying. So I've got a negative cosecant to the n minus 2 x cotangent x. Here I've got a negative, negative, and a third negative. So that will be a minus integral of n minus 2. I've got a cosecant to the n minus 2. And I've got a cotangent times a cotangent. That's going to make cotangent squared. Then our next line was to use a Pythagorean identity to get all cosecants here. So, we bump this over because it's getting a little long. So I'm going to ditto that first term. I've got minus the integral. I'm going to keep the n minus 2. Keeping the cosecant to the n minus 2. Replacing this with its Pythagorean identity and cotangent squared. Pythagorean identity. Cosecant squared is cotangent squared plus 1. Oh, wrong way. Cotangent squared is going to be cosecant squared minus 1. So cosecant squared minus 1. So now it's a matter of distributing. And then I'll distribute that and break it apart. So I'm going to ditto the first term. Still have this minus, still have the integral. I'm going to take all of this, distribute it here and here. So n minus 2 cosecant to the n minus 2x. Oops, I got to add exponents. That's going to make this cancel out. N minus 2 plus 2 is going to give me cosecant to the n. And now, minus n minus 2 cosecant to the n minus 2x. And all of that dx. Okay, the last thing I want to do is distribute the integral, the negative, and I got a negative out here, to both of these and have two separate integrals. So I've got ditto. So this negative for the first one, n minus 2 cosecant to the nx. Now it'll be plus integral of n minus 2 cosecant to the n minus 2x dx. And this is what we were looking for, a reduced power from what I started. Now this term here, I've got n minus 2 of these cosecant to the n's, so I'm going to add it over so adding it over here. So think of this as one of these plus n minus 2. So when you combine 1 plus n minus 2, you're going to get n minus 1. I'm going to bring it out in front of the integral. Cosecant to the nth x dx. And now we're just about ready. So I'm going to go back and pick up this first term that I've been dittoing. Negative cosecant x cotangent x. That's gone, and then I just have this term, plus n minus 2 cosecant to the n minus 2x dx. And our last step now is to divide by this n minus 1. And there's two terms over here. So our final reduction formula will be a negative 1 over n minus 1. Cosecant to the n minus 2x, cotangent x, plus this multiplier will be n minus 2 over n minus 1, cosecant to the n minus 2x dx. Okay, so you have this one to develop today, plus we're going to be using some of these reduction formulas to completely integrate, and I got two of those. They're pretty short. I'll turn the page. So number 2, we're going to use the reduction formula to completely integrate cosine to the 5th x dx. So if we look at our cosine formula, I'm going to grab that. I have it here. I think it's in this book. There it is. I'm going to grab this just so we have it. So when I get the reduction formula, my n is 5. When I go through this, my n is going to be 5, and then I just go from there. So following the formula, it starts out 1 over your n. So that'll be 1/5. Cosine the 5 minus 1, I'm just going to make that the 4th. Sine x plus, now I've got 5 minus 1, that's going to be a 4 over 5. Of cosine, so 5 minus 2 is a 3. So now I still have an integral, so I'm going to run through again where now my n is a 3. So I've got cosine cubed x. So I'm going to come over here because it's going to get a little bit long. So I'm going to ditto this first term. I'll write it all down at the end. Now this 4/5 has to get distributed to both of these terms that are coming. So I'm just going to use brackets for now. Now I'm going to follow the cosine to the nth reduction formula again. Now my n is a 3. So it starts out 1 over 3. Cosine 3 minus 1 is 2. Sine x plus 3 minus 1 is 2 thirds. Integral of cosine 3 minus 2 is 1. I still have an integral, but now it's down to something where I don't need a reduction formula. I know who has cosine as its derivative. So my last step is to write my final answer and distribute this 4/5 and do that term. So our final answer is going to be this first term that I did out. Plus, now I'm here, this will be 4/15 cosine squared x sine x, plus this will be 8/15, and then the antiderivative of cosine is sine, and a plus c. So you're just going to keep repeating the reduction formula until you're all the way down to your final answer. Let's try one more. We're going to do tan to the 7th. So we need the tangent rule. What's nice for you is they are all in your book. We've developed all of them, but they are all in the book in a nice little table. We don't memorize these things. Right here, tan. So I've got 1 over n minus 1. So that's going to be 1/6. Then it says tan to the n minus 1 minus the integral of, it's tan to the n minus 2. So it'll be tan to the 5th x dx. And we keep going. So now I'm going to come over here. I'll keep this 1/6 tan the 6th x minus, and now I'm going to do that reduction formula again. So this, anything out in front, that has to get distributed to the two terms that are coming. So now I go back through it again with n being a 5. So it's 1 5 plus 1, that'll be 1/4. Tan to the n minus 1, that'll be 4th x. Let's see, minus integral of tan to the n minus 2, that'll be down to 3. So now I still have to run through it again with, I'm going to distribute this negative right now. So I'm going to change this to plus, negative, plus. So we've got 1/6 tan to the 6th minus 1/4 tan to the 4th plus, now I'm going to follow the rule again with the 3. So that is 1 over 3 minus 1, be 1/2 tan to the n minus 1 minus integral of tan to the n minus 2, that's the first. And then we have tan, remember that we have the integral of tan on our blue sheet. Down at the bottom, we have all the trig functions to the first power. Tan, right here. And you have a choice between either one, doesn't matter. So we're ready to finish it up. So I'm just going to ditto, ditto, ditto. This last term will be minus ln of the absolute value of cosine x and a plus c. So it's not bad. Just remember to keep, when you go to do it your second time, make sure you put brackets around it and distribute what's in front. And that's it.